And welcome back, everyone. Again, great choice for picking the Java part of the evening. I hope everyone had good conversations in the networking carousel. Always good to have a community where people talk to each other. So, for our second talk tonight, we have Ben Stopford. And Ben Stopford is a lead technologist at Confluent, the company that supports Kafka. And Ben is going to give a talk about the strategic importance of data in motion. So, Ben, welcome, first of all.
Thank you.
And Ben, data in motion, how would you characterize the difference between data in motion and data at rest?
Yeah, I think it's the other side of the coin. It's just the one that we maybe haven't spent as much time with. But this talk today is very much about understanding not just where we put data to keep it safe, to ask questions of it, but how we sort of set it free across our company and the benefits, particularly the strategic ones that go hand in hand with that.
Great stuff. So I look very much forward to your talk, learning a lot about the strategic importance of data in motion. So without further ado, take it away, Ben.
Cool, thanks very much. So firstly, thank you all for having me today. It's a real pleasure to be here. I said I work at Confluent, which is it's the company that's basically set up by the people that originally wrote Kafka at LinkedIn, and I've been there for a long time. I was an early employee, and so I've been doing this for a fair while now, pushing 50 these days, which I find somewhat shocking, and that actually makes me a proud member of Generation X. I'm not sure if there's other Generation X folks out there in the audience. I bet there's a few. But the interesting thing about Generation X is that we're basically the last generation that really lived in a world that didn't have the internet. So we remember being bored. We remember a world before there was like mobile technology that kind of keeps you entertained all the time. Back when, televisions had cathode ray tubes and you used to have to wander up to the front dial and like turn it to change the channel, like click it around, which of course didn't matter too much because there really weren't that many channels to choose from. But certainly that's a very, understanding that world, it feels very, very different to the world that we live in today. And I think I really like this picture. This picture really sums up change for me. I mean, I have kids about this age, and you show them a phone from the 1980s, 1990s, and they literally have no idea what it is. And there's a good reason they have no idea what it is, and that is that this phone does absolutely nothing. Has none of the features that they think a phone should have. I mean, you can't like check Facebook on it. You can't text your friends. You can't play video games. You can't watch a movie on Netflix. You can't do like a whole host of things that they think a phone should be able to do. And yet we probably, if you're a Generation X person, you still think about that being a phone in the same way you might think of a phone being today. So the point here is really that the world is changing. But that's kind of obvious. We all know the world's changing. What's really more interesting is that these changes often aren't that apparent at the time because they're sort of happening slowly and organically. It's only when we stop and look back and we think about the difference between the world now and the world then that we realize how massive and important some of these changes are. And that's kind of what I wanted to focus on today. I want to focus on one of these changes. And this is particularly a change that we see in business. It's a change that's happening now. It's a change that's actually super obvious when you think about it, but you might not have really taken the time to just sit back and think about it as being as big a change as it is. And this is really, in its essence, it's about the role of technology in business, in the businesses that you and I all work at. And the essence is really that technology is changing from being a support function function that kind of helps us do our job better, to being something that really defines what a business is at its most visceral level. So that seems a bit abstract. What does that actually mean? Well, what it means is that we used to build software which was designed to help us as humans do our jobs better. So we'd either build some software or we buy some piece of software which kind of makes us do our job better, or makes us, makes our life easier in some way. So let's say you're a trader in a bank. You're probably going to have a bunch of software which somebody built for you or you bought, which helps you trade better. It's going to help you manage your bookings. It's going to help you ascertain risk on different portfolios. It's going to help you actually make the trades, move money into the market, etc., etc. These are all tools which would help you as a trader do a better job. But increasingly, we're seeing this kind of shift where the business is becoming fully automated, fully enabled by software. It's not just helping a trader do its job, it's actually taking over that role of trading algorithmically. And the trader then becomes a person that sits and monitors that workflow, not actually on the critical path. He's just there to interact when things go wrong or to talk to customers, etc. So this shift is really about us, technology, moving from being this support function that helps us do our job better to the primary sort of implementation of our business. And you can see this, it's not just a finance thing, you can see this in every single industry. I mean, I don't know if you guys had Blockbuster, if you remember Blockbuster. If you didn't remember Blockbuster, you will certainly remember a store that was very similar to it, a store where you could go and rent yourself a DVD and you'd wander around and look at the various different DVDs and work out which one you wanted to watch, and then you'd go home and plug it into your DVD player. It seems really strange that when you think back, to think that Blockbusters was actually a competitor of Netflix, because when you look at Blockbusters, it's so obviously a bricks and mortar store. It's a physical store, but of course it had technology, right? It's got tills, it's got systems which linked all those stores together. It manages inventory, all of these things. These are all technology that helped Blockbuster be successful for as long as it was successful. But certainly when you look at Netflix, that does not seem like the same type of business, when of course it is the same type of business, but it's a business which is defined wholly in software. And we see this in other industries. We see this in banking. Banking customers are, the change is more about customers' needs. Customers expect to be able to do things on their mobile phones. They expect there to be a seamless user experience. You want to be able to check your bank balance or make a payment when you're sat in the bar or going to work on the tube or any of these places. This has really raised the bar, and banks have had to respond to this. Taxis are actually one of my favorite examples, right? This is a wonderful example, because rather than having some taxi operator sat in a little hut somewhere with an Excel spreadsheet and some basic piece of software which helps them manage the various different cars that they have, the various different taxis that they have on their books. Instead, we've seen that replaced by software implementations which automate the entire process and don't just do what that taxi operator did, but actually significantly raise the level of user experience. It's significantly changed the way that we actually think about what hailing a taxi is. So again, a move to a software-defined business. We see this in cars with the increasing, which are once the kind of realms of mechanical engineering, the home ground of mechanical engineering is, of course, the car. But today, increasingly, it's more the home ground of software engineers. Because we have data inside cabs, we have the internet connectivity, both inside the cab as well as inside the engine itself. So we see this all over the place. We see it in transformation, in transportation, we see it in retail, we see it in finance. This is just to name a few examples. So we have the shift from kind of technology which helps other people do their jobs better to technology which actually automates business processes. But what is it that really enables this transformation? Well, it's really four things. It's cloud, machine learning, it's mobile, and it's data in motion. And each of them actually has a pretty significant effect in a very, very different way. So cloud is a great example. I think most people, when they think about cloud, they think it's just about grabbing somebody else's computer or having some data center. It's actually not, that's not the really pivotal change. The really big pivotal change with cloud is actually the pricing model. It allows you to have access not just to servers, but to incredibly complex pieces of software which are run for you in a pricing model that does not require a massive CapEx expenditure upfront. What that really means is you can build far more sophisticated, scalable systems on a relatively little budget, which is delivered incrementally. And that's the real step change. That's the thing that really allows these businesses to fully automate their software. It's a change in the pricing model. It's the change which actually has an influential, then an ongoing change on the way that we architect and build our systems. Machine learning is also a pivotal. It's still actually, to a certain extent, in its infancy, but certainly its ability to help us train models which automate decisions is obviously a primary driver for a whole class of automation projects that help businesses automate their core workflows. Mobile, as I mentioned before, probably the main thing with mobile is it's just changed the way that customers expectations of our software. Right? Customers expect these unified user experiences, and if a company can't provide those, then they're going to go somewhere else. But certainly mobile provides the connectivity and that always-on experience, which means that we can fully automate something and have it available 24/7, and that customers are expecting us to provide services that provide those level, a computer's level of service. And then finally, data in motion. This is really the focus of this talk. The data in motion and event streams allow us to connect a whole organization together with real-time data. And what that really means is that real-time data is available everywhere. Whether you're in a different data center, whether you're on the other side of the world, you can always access data which is at its most fresh. So why is that important? Well, a nice analogy for this is, would you cross the road with information about that road that was 5 minutes old? Of course you wouldn't. It would be very foolish to do so. And so would you want to run a business that's based on information that's 5 minutes old? What about a day old? What about a month old? The more fresh information is, the more value it has to your business. And there's actually very little downside. There's no real reason to not have real-time data in today's world. The technology is there to make these things possible. When we have a whole range of data in motion technologies that complement those that operate on data at rest. So no matter what industry you're in, this real-time data is always going to beat slow data. And this really comes because the value of data is at its most, is at its greatest at the point that it's created. And it sort of trails down from there. It never goes to zero. Right? The value of old data is never zero, it's just less. But it always has its most value in the moment that it's created, because in that moment is when you can act on it. That's the moment that you can do something that's useful for your customer who's there online waiting for you to react. So this has some significant implications for databases. So why is that? Well, the reason is that databases have a fundamental working assumption which we all take for granted. And that is that data is passive, that you put data into a database and that's where it stays. That's their fundamental assumption. And there's nothing wrong with that assumption. It's actually a wonderful assumption. And databases are wonderful pieces of technology. They keep our data safe. They allow us to change it in different ways in a very safe, regulated manner. It allowed us to ask incredibly complicated questions about data, questions that we could never answer ourselves, and find accurate answers in a matter of milliseconds. But they are fundamentally passive. They are a place where data goes to sit, and it's a place where data is resident, it is at rest. So you can ask, with a database, the fundamental assumption is you ask queries, you get answers, the data effectively stays put. And the reason for that actually links back to the place that we started. Because databases are really a technology that's designed for that era where we built technology which helped us, which helped the taxi operator, that helped you do your job better, that helped the trader to do his bookings, to build the systems that help us do our jobs better. That's what databases are for. They're designed around us. So if you take something like processing a loan application in a financial institution, that is a workflow that's based on many different users. Some borrower creates an application form, and it goes through a credit officer, a risk officer, and a loan officer, and eventually gets approved and rejected. And each one of these people has a bunch of software which is based on a database that helps them do that particular role better. That's why it takes a long time. That's why loan applications take a couple of weeks to get through, because of all of this kind of manually driven process. But if you imagine a loan application in software, and there are a number of vendors that do this, they can provide you with a loan application that's automatically validated in a matter of seconds. This is not a piece of software which is built on a database where you ask the database questions and get answers. It's a piece of software which connects a whole range of different services together with real-time data, with real-time streams of events. So data connectivity is the thing that's important here, rather than locking up data in a database somewhere. And hence we end up with these systems that are able to provide loans in seconds. So that classical application architecture, where a human talks to a user interface, which talks to a backend service, which talks to a database, asks questions and gets answers, it's not that it's less important, but it's increasingly being augmented by these architectures where pieces of software talk to one another and orchestrate around streams of data that move between them, so that the system is basically always on and interacting with other parts of the software system. So a great example of this, I said it was one of my favorites, is the ride-sharing application. If you hail a ride, if you ask for a ride, you get you're creating business events on your phone. Those events shoot back to a whole range of backing services, which make make sure that the booking actually happens, figures out which drivers are in your vicinity, how close they are to you, sends out an event to each of those phones, tries to get one of them to accept you. When they do accept you, notifies it back again. There's geospatial information involved in that search. There's more geospatial information that's tracking you as you take your ride, and let's say you reroute because you go in a different direction, or there's some kind of collision or whatever it might be. These are all different services which are interacting with a number of different streams of events, whether it's positional information or business information, all joining together an automated process that makes a business work. So data in motion is really the thing that makes this possible. I really like this analogy of it being a kind of central nervous system for your business. Kafka sits at the heart of this. This is the technology that moves this data around the company. It can store data for long periods of time. It can scale to very high volumes, but it always provides that information in a matter of milliseconds. So you end up with this kind of central nervous system for your business, which connects together all these different parts of the enterprise, and Kafka and Confluent help provide this. So I think the final example I want to give is a really good example of why having this kind of real-time central nervous system is so important. And this is something that you should find very easy to understand, because it's something that we all do. So let's take this example of a retail example. So something like Amazon, right? Everybody uses Amazon, I think. And Amazon actually has a kind of central nervous system based on events that joins a lot of its technology together, because behind Amazon, behind that simple website, there is a whole bunch of different services which are doing a whole variety of different things, from serving you web pages to shipping different, items that you bought to your door and telling you how far they've got, and all of these different activities. Many different pieces of software spread around the world are making this all happen. But when you search for something, there's a whole bunch of these processes going on. Your activity is being captured, every click event or every single click stream is being analyzed. You're getting personal recommendations. So think about something like, you're going to go and buy, let's say it's a camera or an iPad. You go to buy like a camera, Amazon, you go to the page. Amazon's actually pretty clever. It can tell you exactly when they're going to deliver it. So for example, if you're a Prime member, you can maybe get that camera by 7 p.m. that day, on the same day. So how does that work? How is Amazon able to guarantee same day delivery? Because there's a lot of moving parts in that. So it has to know your location. It has to know the location of each of its repositories, each of its warehouses where these cameras are stored. It has to know what inventory is available in each one of those. It has to know that information in real time. It has to know whether or not the logistics system that's going to ship it is going to be able to deliver it from a warehouse that has your inventory to your door, and it's not over there's room within the various different vans to make that happen. All of this information is only possible if the different services that make up this architecture are synchronized together with some level of real-time information. You have the inventory in the various different services that are actually providing this information to you as a user. It's a kind of central nervous system of data that makes data available across an organization that makes this possible. So when it comes to Christmas and you realize that you forgot your present for Aunt Jennifer, it's quite likely that Amazon is the place that you're going to go for, because you trust that they're going to be able to get it to you on time because you've done it before, and you know that they're reliable. And they're reliable because they have the infrastructure for real-time data that makes these kind of things possible. So messaging is really a central nervous system. It's something that's based on these messaging technologies like Confluent in the cloud, or Kafka if you're on premise, open source, where you can publish, subscribe, you can store data infinitely, and you can analyze that data and process it just like you process data in a database using SQL, but not for data that's locked up, but for data that is moving, for data in motion. So finally, why the strategic importance? So hopefully that idea of the central nervous system is pretty compelling. But why is this so strategically important for businesses right now? Well, for me, I think there's a few reasons for this. Certainly for the customers that I talk to, these are the reasons that I see. And the first is that most companies have pretty complicated architectures already. So this is kind of a basic architecture for a bank. If any of you have worked in a bank, you'll know that no bank that I've ever come across has got an architecture that's this clean or simple. It's actually way more complicated. There's way more systems involved. And the reality of most companies is they actually have these very complex interconnected architectures for good reasons, because actually the business and the organization itself is complex and interconnected. And maybe it's not perfect, but it's just a reality of most of the businesses that we work in. There is a level of complexity there. Secondly, technology innovations actually drive decentralization. So the technology innovations of today, microservices, data mesh, etc., each of these movements actually encourages us to decentralize our applications, to break them up into different pieces, to allow them to run separately. So again, we've got another force, which is making our architectures more decentralized, more spread out. Next, thirdly, globalization. Companies increasingly, these software-defined companies that we've been talking about, are increasingly global entities. They have services which are not just deployed in one data center, not even just 2 data centers, but often spread around the world in a variety of different geographies. So they need these kind of hybrid setups that maybe span different cloud providers, that maybe span different geographies. And this again decentralizes the architecture, makes it more spread out. Actually makes the software more complex in some ways. But the counter to all this is that on the other side, users expect a unified user experience. When a customer comes to your site, to your app, or whatever the user interface is for the company that you work at, they expect something that completely masks all of that complexity, that completely masks all the microservices and all the regions and all the legacy and all the different cloud providers that you have. They don't care how much complexity there is back there. They care that they can make a payment when they're sat in the bath, or they can check their bank balance when they're on the train on the way to work, or that they can call an Uber from outside the pub that's going to get them home. That's obviously what they really care about. But these two things sit in tension, right? Companies are in this state of tension between the increasing complexity of software and the completing distributed nature of it, decentralized nature of it, and the need to actually innovate, which typically makes things more complex. And then that being balanced with the fact that users want it to be simpler, they want it to be more joined up, they want a single pane of glass across this entire entity. And the real conclusion for this for me is that organizations need data, or people in organizations need to have data that meets them where they are, right? So you don't want, you need, if you have a new application that you need to build, if you have a new service that you're working on, or maybe like it's a legacy application, you need the organization's real-time data to meet you where you are so that you can innovate. And that's why we see these shifts away from classical formations, which are monolithic, whether it's monolithic applications or monolithic data warehouses, places that kind of condense data and function in one place. And we see movements like microservices, which are decentralizing those data mesh, which is about avoiding having a single point where all the data accumulates, instead having something that's based on data products and spread in a decentralized way, in a domain-specific way around the organization, all based on real-time data flows. So that's, for me, is the strategic importance. And the answer really is that data in motion helps us with this, along with those other 4 tenets of machine learning, cloud, and mobile. But data in motion really helps us because it meets you wherever you may be. So that's me. My name was Ben Stopford. You can email me. You can find me on Twitter at Ben Stopford. And yeah, it was a real pleasure to be here. Pretty abstract talk, but if anyone does have any questions, I'm more than happy to take them if we have time. And thank you very much for listening.
Thank you, Ben. Great talk. I think you really showed indeed the strategic importance of data in motion. There are a few questions. We'll take you through them. First of all, a comment that the machine learning icon is very awesome, very Terminator-esque, Skynet-esque, very good. And the first question we have is, so nowadays we get more and more data. The volume of data that's being generated is ever increasing. Is there a limit to the amount of data that Kafka can handle?
Yeah, in theory, yes, of course, everything has a limit. You don't reach it very often. So I think the only there are a few companies that probably push the upper end, and it's not so much that Kafka can't do it, because it can. It's actually more to do with operation. Like if you look at the architecture of someone like Netflix, they have like a gigantic data pipeline. It's got like literally all of their information goes through this sort of central Kafka instance. It links together hundreds of different microservices. And they used to just have like one massive Kafka installation. Now they actually have a set of smaller ones. Actually, Apple does the same kind of thing, and that's really more about kind of it's more about managing it. It's like they have like some very high throughput single use cases which are sort of isolated on one set of clusters, and these are big clusters, right? Each of these clusters is like hundreds of machines. Rather than going into like the thousands, I think the biggest I've ever seen is 1,000, just over 1,000. But rather than going to those very large clusters, which do get a little bit difficult to maintain, they tend to try and break the things up into smaller ones.
Thanks. So another question from the audience. Going back to the example use of the little girl crossing the road, how can you, in a system where you use Kafka, ensure that the quality of the data and the recency of your data is good enough to make such critical decisions?
Yeah, that's a great question. Yeah, I mean, if you use Confluent Cloud, then there's a whole bunch of different governance features in there that make it really easy for you to improve things. You can define schemas in a range of different protocols, whether it's JSON schema or protobuf or Avro, which allow you to then communicate and manage the change process around how data changes, because that's actually one of the most biggest sources of error is actually people just making mistakes when changing data. There's also governance features like data lineage, which allows you to track where information is going through the organization. So that's really important. If, for example, you do realize that something's broken and you need to know where that bit of data came from, and it's not just totally apparent, you can use a data lineage solution to get you back. So yeah, I think, and then honestly, I mean, data quality it's kind of a dark art, but a lot of it comes down to, I think, the implementation. And I know it sounds, maybe simplistic, but simple architectures are actually the best approaches for these. So like a single event streaming platform or data mesh or whatever technology you use that allows you to kind of keep sources and sinks close to one another. And importantly, some of these principles like having data, the best principle in a data mesh is this data as a product thing is a really important thing, which is really just about saying that people that create data, like if I have a system that creates data and gives it to other people, it has to think of itself as a product, it has to think about how important its role in the organization is. And that's actually the big thing that most people don't do. Like, I'm a trading system, I make money.
Yeah.
My job is not to like provide you with data. I give you some, you're really lucky that you get it at all. That's the wrong mindset. The right mindset is my job is to provide this information to the rest of the organization because it's really important to them and it needs to be really high quality. So that kind of mindset shift is actually arguably more important than the technical ones.
Yeah. Great answer, thank you. And one more question for myself on this criticality, right, of up-to-date data. An event streaming platform is inherently asynchronous. You put an event on a topic and someone else process it. How would you then handle critical events that need to be handled synchronously, where you need to be sure that stuff happened? Is that something you would then take off a Kafka platform and handle directly, or how would you handle such a event?
Yeah, I mean, there's kind of two ways you can go with this. I mean, there are many asynchronous platforms that guarantee that data is processed. That's very common. Like, it's definitely going to happen. It's just not necessarily clear exactly when it happens, but it's going to be within some window. And the way that you get around that is you monitor your services. It's like, are your services up and processing data? In which case, everything's fine. Yeah. The second part of that is like whether or not you require like a response. So let's say that like I buy an iPad, I actually want to know that, like, I want some kind of visual confirmation that comes back to me and says, yeah, that happened, right?
Yeah.
did actually buy this, or I bought a flight and it's actually booked, right? Am I going to go? And for those things, I mean, you can do them with event streams, and people do, but there's nothing wrong with using a request response technology. I mean, if you want to ask a question and get an answer, it's like back to the database analogy. You're a human, you want to ask questions, get answers. REST is a great way of doing it. There's a bunch of different options, but primarily you want to be using events for those asynchronous processes that move data around and allow you to decouple an architecture, because the problem with request response is it works great for that interaction between a user and that first server, but if you start linking more things together, it becomes much more tightly coupled.
Yeah, you get bogged down by everything being tied together.
Yeah, in most systems you want like a balance of both, right? You want a bit of request response, you want some events.
Well, great stuff, great talk, very interesting. I think we've all through the questions we've got. So Ben, I want to thank you for your time with us and for inspiring us about the importance of data in motion. We'll go to a short break after this, and when we get back from the break, my colleague Donald will be back here as well, and we'll close off the night together.
Cool, thank you.
Thank you.